Okay, now we gonna have a quick talk about the gravity force. Because again, if you go back to the physics, we can figure out what this gravity force is. So, gravity force is gonna be mass of object 1 multiplied by mass of object 2 multiplied by g, its gravitational constant, and divided by square of distance between them. When we're talking about gravity, so m1 it's gonna be mass of our object, m2 it's gonna be another mass of the bigger object. In our course, when we're talking about gravity on Earth, this is Earth gravity. m2 is mass of the Earth. So it's super big, and we have gravitational constant, right? And distance between them. Okay, if I have one object here, another object here, and here is the Earth surface, yeah, we can tell that the distance between the center of the Mars will be different. But distance go not to the surface, distance go to the center of the Mars or to the core of the Earth. And even if you're gonna be like 1 kilometer away from the Earth, the distance to the center of Mars gonna be not so much different than the distance of the object on the Earth surface, because diameter of the Earth by themselves is very big. It's 1000 kilometers, right? So this we can ignore, and this is we also can pretty much ignore because this is like very big object. Basically this and this is constant, we can call C, and this is constant is we can call G. This is gravitational constant 9.8, and when we apply force, gravity force, it's gonna be mass of the object multiplied by G. But when we calculate our acceleration, you remember that we divide our force on the mass. So in the case of the gravitational force, acceleration gonna be equal to the G at the end. So for this we need to make a little bit small fix here. We can do it two ways. One way, I can create another function for gravitational force. I can call it void apply gravity, and again we know that gravity is the same, so this I can call p vector gravity equals new p vector 0 and 9.8. yeah, but okay, we get the smaller value. 9.8 is too big for us now, and this acceleration at gravity. So all the difference we don't need to divide back it to the mass. So this is one of the way. So now to apply gravity, I can just write this, apply gravity, that's all. Another way, I can use this gravity vector, but I just can here multiply my gravity by mass. So this is another way if I don't want to write additional function, but this is kind of we gonna do multiplication twice. We're gonna multiply gravity mass and after divide on the mass, so it's kind of we're just spending time to do like calculations and we not really need to do, right? So I will delete this one, and for gravity we will use this force. So now I can apply gravity for my object. After I can apply other forces. I have one wind, I can have like another force for wind. And let's do one more things. Do not let our balls go out from the screen. I can just like, so it's just better for us to see. Void check borders, and here I can write, okay, if this position x less than mass multiplied by 10 here, right? Why I do it? Because I wanna the border of my ball bounce from the screen, not the middle of the ball, you remember? Or this position x more than width minus size, not size, minus mass multiplied by 10. If this happens, what I do, I gonna just invert velocity. This velocity multiply. Okay, I wanna invert just x, this velocity x, and this velocity, or I can do like this, just like multiply by -1. And the same I can do for y. Y, this mass y, height, this velocity y, and let's just do it where we do it here before we, yeah, let's do it before we add velocity. This check borders, okay, right, I save it and I run it, and now I can see, okay, how it's moved. Yeah, I think I need to move it after I add to the position. Now here one more things, because divided by 2, because this is diameter of our object, right? But I need to get radius. Okay, now you see it's pretty much right. Let's delete this print statement. Where is this happened? Print. Okay. It slowed down our program first. And let's do one more thing. It's quick. We can add the bounce coefficient float. bounce coefficient, let's say 95. I'm not gonna talk much about this now, but you know, when the object hit something and bounce back, it's gonna lose some of its power, some of its energy, right? It's gonna transfer. So I will just, okay, let's 0.9. I will add this bounce coefficient, so when it's bounced from the border, it's gonna be minus bounce coefficient, right? And here minus bounce coefficient. So we're gonna lose some power. You see with ball like bouncing, it's not gonna bounce with the same power it have, okay. If, okay, you will see it better if I will delete wind now, first of all, and let's create another one, float gravity, p vector gravity equals new p vector 0 1, and this I can delete here. So now if I want to change gravity, I can change it here. Okay, it's a little bit strange behavior. If I put -1 here, this happens because when it's hit this, it's already some part of the bell down, so it's not gonna move up too much. So it's to fix this part. So when it's hit ground ball, some part of the ball already on the ground. So when I do next calculation, it think okay, it's again hit, so it's reverse again speed, right, velocity. So to fix it, I need just to do something like this position x plus this velocity x. So I will just move it back when it bounces directly first, and the same with y. This should fix this problem. Yeah, now you see it's just like bouncing there, and I can create the bigger gravity and make speed limit 20. So now it's gonna go much faster, and it's bouncing, and because it does not use bounce coefficient now, it's gonna bounce forever. Right, because it's hit there, it's invert, and it reaches the same point where the gravity turn it back, so it's that's why we have bounce coefficient, and now it's gonna be pretty real behavior. Bouncing too small, and at the end it stop and it's go down again. Okay, this part we gonna work more next class and fix more. We finish for today. I repeat it, check the materials, check the book. I will attach the link. Have a good week.